while we go through some of these technical issues. I can probably start talking. You can hear me okay? Yes? So I think we need to shorten the bio. The bio is too long. My name is Amol Mitra. If anybody knows Gujarati, then I can speak in Gujarati also because I'm from Baroda. Anybody? Nobody? Sometimes at least one person who can speak Gujarati. Anyway, so my name is Amol Mitra. I manage the Asia Pacific business for HP Networking. I'm here on a different kind of presentation I'm going to do today. I'm going to primarily talk about more of an educational aspect of SDN. What is SDN and why is it important and why it is going to change what is happening in the networking space. So good news is we're about 15 or 20 people, so we could have just done one small round table and we could have talked, but I'll try to make it more of a conversation rather than a presentation. So if you look at what is happening in the networking industry, networking industry always used to be what I used to say about speeds and feeds. So whenever you have a problem, like your application is not running or your email is slow or your video conference is not running very well, you usually call the networking IT manager. They say, "Sir, kya ho raha hai? Nothing, chal nahi raha hai, it's going very slow." Then the IT manager says, "No, I know why, because you're on a 10 megabit network." So when he says, okay, you upgrade to a 100 megabit network, jaldi chalega. Then you go to the 100 megabit network, you say, no, abhi bhi nahi chal raha hai. Okay, main gigabit network kar raha hu. So you move to gigabit. Then you move to 10 gigabit. Then you move to 40 gigabit. You get to 100 gigabit, right? Networking industry has always been about throwing bandwidth to the problem. That's usually the mentality people have, whether IT managers or network managers. But what is happening now is that mentality cannot scale. And it is limited by the amount of diversification, the amount of sites customers have, and really the amount of information which is traveling. So I'll give you an example. If you look at social media, how many Facebook? Anybody Facebook? You are doing Facebook right now probably. Instead of listening to me, that's okay. But if you do Facebook, about 30 billion pieces of content get added every month, right? Of content, that's just data. On Facebook. I'll give you another example. There's a company called Zynga. A company called Zynga. This is a gaming platform, an online gaming. For those of you who are gamblers or casino people, then you can go to Zynga. And you go to Zynga, and it's a gaming platform. It's not just for gambling. It's a playing medium. But if you look at the amount of traffic it generates, because it does what is called multiplayer games, right, around the world. It generates about 1 petabyte of data. Every day. So this is a social, gaming platform which does that. I'll give you another example. There's a cosmetic company called Mary Kay in the US. It's also in India. There's about 160,000 sales reps of Mary Kay. They access information every single day on either their iPod or their Android iPhone, or their Android smartphone. Just in China, right? There's 160,000 reps today from a statistics perspective. In China, they access that information. So overall, if you look at, the reason I show this slide is, I just want to make sure that you understand that the amount of data which is getting generated on the network is tripling, right, every quarter. So every 3 months the data is tripling. So it's a big issue from a networking perspective, because we are the plumbing which sits behind all these end devices which are accessing this information. So when you have an application or a game, as an example, which comes online, what do you need to do? The network needs to adopt to the application, right? Now I take an example, right? Let's say for one game, there are 10,000 rules which need to be defined on the network to program the network. This is an example, 100,000 provisions there. That means there's about 20 commands you need to apply to a network switch, right? About 20, if it's an example we're taking. The whole point of this example is that what you're trying to do is, when you bring up an application on the network, you need to go manually reconfigure or configure switches on the network to support and optimize and effectively drive that application on the network. And as just one example, if you take 1 minute per command, and there's about 200,000 commands which need to be entered on a switch per day, that's about 3,333 hours of effort. That's about 420 network administrators who you need to go just manage that application on the network. So you think about from a scale perspective, it is extremely hard to scale something like this when you have thousands of applications, like the gaming applications, coming online. So in the networking space, you need to do something different. And the different thing is software-defined networks. It is different because it doesn't add bandwidth, doesn't throw bandwidth to the problem. It makes the network more intelligent, more programmable, and more adaptive to applications on the network, because that is what matters most. It's not the performance of your gigabit network, it's really the application performance which needs to be managed. And SDN gives the promise of managing applications effectively and in optimized, agile way. That is what SDN is all about. That is why SDN is very hot. And in the networking space, everybody talks about SDN because it's a hot thing right now. And the standard, much like the IEEE organization, the standard body which is driving this effort is called ONF, which is the Open Network Foundation. That is the standard which is standards body which is driving the SDN standard definition. And this is a definition from the ONF SDN abstract. And you look at what they're trying to do is they're trying to abstract the control plane and the data plane of the network. So network today, the control plane and data plane exist on a switch. What they're doing is now they're trying to move the control plane and data plane and separate that from each other. So that now you have one central intelligence controller which is controlling all the switches on the network, programming all the switches on the network, adapting and making the entire network agile based on the application which comes online. That is the concept. The concept is make the network more abstracted. Don't put all the intelligence inside a switch. Have one switch or one controller control the network across the entire environment of a customer network. Yeah? So, what is SDN? Yeah? So, there are three layers which the standards body have defined within an SDN environment. The first one at the bottom is the infrastructure layer. The second one is the control layer, and third one is the application layer. So, it's a very simple architecture. There's complexity, but there's still a very simple architecture. The infrastructure layer is where the switches reside, normal network switches. That is where the switches reside. The control layer is where the SDN controller, which is a smart, intelligent device which enables the programming of the entire network automatically. Right? So that's where the controller sits. And on top of that is the applications. So these are applications like load balancing application, or you can have a security application, and I'll talk about it in a second, which will make more sense. But these are the different layers of a basic SDN environment and basic SDN topology. The thing at the bottom, which is this infrastructure layer, what has been defined today for the infrastructure layer are traditional switches, so any switch you can buy from any vendor, but the key capability you need in the switch is a standard called OpenFlow. OpenFlow is a standard which sits inside, it is like a protocol which sits inside a switch, which enables the SDN programmability to happen in an open standards fashion. So that is what you need at the end, at the lowest layer, which is the infrastructure layer. So companies like HP, who manufacture network switches and who have a strong business in the network switching space, have now enabled their switches to support OpenFlow. And we have about 40 models of switches which can support OpenFlow today. So today, and we're the only vendors who can do that today from a scale perspective. So we have infrastructure switches which support OpenFlow technology, which basically makes it ready to be supported in an SDN environment. The second portion is this thing called a virtual application network SDN controller. In short, it's just an SDN controller. This is where the intelligence of understanding which application is coming on the network and how to effectively optimize that application is sitting in this controller. So I'll give you an example. Let me give you an example of a company. Have you heard of HBO? Yeah, TV? Yes. Yeah, HBO, right? So have you heard of HBO? They are a company who is now moving into what is called online streaming of shows, right? So if you have YouTube or something like that, you can go and watch it. But now the media, if you buy a TV today, ever bought a Samsung? If anybody has a Samsung TV today, there's something called a smart TV you can get. That means you can run on the TV, you can run a show which is being streamed from a channel like HBO. right? You can do it today, right? Or Netflix, if you heard of Netflix, same concept. So what they've done, they've taken the biggest issue right now of streaming video is security. The biggest issue is they need to make sure that whatever they're streaming is securely getting to your home. That's one of their biggest issues. So what they've done is they've put in an application called Sentinel Security Application. This is an application which enables basically the network to find malicious viruses or malicious content, and it can go detect it, it can sniff it, and then go quarantine it. That's the concept behind it. But what they've done is they've put in an application which can talk to an SDN controller in an open standards way, and then the SDN controller knows, oh, this security application came on the network. I need to go program all the switches automatically. I call it automatic magic, automatically across the entire network to make sure that an application runs smoothly, and if there's any virus or any malware which is detected, then it can be detected automatically, instantaneously, without anybody having to go and manually configure a switch. Right? That is one of the applications. I'll give you another example. There's a company called CERN. Have you heard CERN? The Center for European Nuclear Research, right? These are the guys who make energy, make mass. This is something called particle, they make mass. They have, what are they? Load balancing application. Because they're running the entire environment across Europe and worldwide. They're trying to build a load balancing application which enables their environment to work seamlessly and get very, very high performance of 10 gigabit of the 10 gigabit network. That's another example of how a company like CERN or HBO are trying to build applications so you can optimize the network automatically and program the network so that the application can run effectively, automatically, and in an optimal fashion. I'll give you some other examples in a second. Have you heard of Microsoft? Anybody heard of Microsoft? I just want to make sure everybody's awake. Yeah? So, if you heard of Microsoft, right, they have an application called Link. Okay? Yeah, yeah, it's for free. So, if you get a Link application, and from a Link app, you can run voice, you can do a voice call very much like Skype, you can do a voice call, you can do a video call, you can do unified messaging, communications. The thing about Link, if you're using Microsoft Link, is how do you go optimize the voice traffic, how do you go optimize the video traffic across the network automatically? So if there is something on the network which can say, oh, there's a Link application, and Amol, me, I want to talk to Surya, who's in the audience here, or if you want to talk to them, how do I go and optimize that voice traffic so that there is no deterrence, there is no inhibition to the voice traffic traveling. If you can do that automatically and program it across all the switches, now you're talking about something very different. Now you're talking about the network being intelligent to go detect the application, program the network automatically for that application, and now you're running an efficient, optimized network without having any human intervention in defining and configuring them. Now that is cool. That is a promise of what we're delivering with this software-defined network technology. Yeah. So, as a matter of fact, I talked about HBO, I talked about CERN. With Microsoft, we've already launched the UC&C application with them, where we are optimizing Microsoft Link conversations, video and voice traffic across the network. So it is something which is very, very promising, and you'll see a lot of vendors, not just us, in the OEM vendors, hardware vendors, and you'll see a lot of ISVs drive applications to really optimize this environment and make the environment more programmable from a programmability perspective. So if you scale this beyond the three examples I gave you, you can think about applications, an SAP application, a Polycom voice application. You can look at I talked about Microsoft Link. You can look at applications like Microsoft PowerPoint or Excel, which you want to go and optimize on the network from an Office Suite perspective. There are several applications. If you think beyond, like I do 5-10 years, if you think beyond, you can think about something like an app store. Have you know what an app store is? You know what iTunes? Maybe have. Is BlackBerry more prevalent in India or iPhones? iPhone.
Android.
Yeah. Okay, have you gone to Google Play? Yeah, Google Play, Google Play. So, Android. In the US, everything is everything. But if you look at applications like Google Play or something like that, you think about these apps becoming an app store. And the real promise is that once we build an SDK, which is available to anybody in an open market environment, which can communicate with the SDN controller, and if the SDN controller can intelligently look at the application and say, I know this application, I know what to program, I can automatically do it, you can think about an app store for these kinds of applications and drive it across the network environment, which is very unique. So now the concept of throwing bandwidth to the problem doesn't come, because now you've optimized the network and scale the network more intelligently than anybody else can do in the industry. That is why this thing is very, very hot. If you look at it more diagrammatically or more, this is what we pay at HP marketing people to do. This is a marketing slide which shows basically a whole bunch of applications. There's an SDN controller which is orchestrating, which is virtualizing and the entire network, and below are all the switches which are getting automatically programmed, right? That is the promise which SDN provides, and today we are seeing customers and applications and ISVs driving this kind of a solution. Make sense?
Yes.
Yeah, it's really cool. It's actually something which is going to change the networking paradigm in the future. You move now from managing the infrastructure. You don't really manage the infrastructure. You manage the experience on your experience as a customer on the network. That is what you're doing. So in the networking space, usually you think about managing the infrastructure. How are you going to manage the switch? How are you going to go configure the switch? It's no longer about that. It's about how you're making your experience on the network better. That is the promise behind this SDN technology. Now, I know I'm part of the track we are on is the IEEE track. So I have the obligatory standards body slide. So these are the standards bodies which are working on the SDN technology. I talked about ONF. This is the Open Network Foundation. This is the standard body where the SDN definition comes from. There's this technology I talked about, OpenFlow, which needs to sit on the switch, that is built by the OpenFlow Forum. There's another technology called NFV, which is Network for Function Virtualization. This is more for service providers and driving SDN concept in a service provider environment. That is being developed in a standards body as well, the ETSI. And then finally, there's two stacks. There's a cloud stack and there's OpenStack. The OpenStack environment, which is the application layer standards body API, is being developed in the OpenStack Leadership Foundation. Yeah. So there's multiple standards body working on the SDN concept and driving different areas, whether it's the infrastructure layer, the control layer, or the application layer in the marketplace. What have we done from an HP perspective? We are one of the pioneers in driving the SDN concept. We are one of the only vendors today who have an end-to-end solution. We have applications. I talked about customers whom we develop applications with. We have the controller, which is the SDN controller. And we have obviously the infrastructure, which are our switches, which are managed and support and OpenFlow technology. So we have an end-to-end solution today. We have about 60 customers who today are already working with us in the beta program to develop applications. I talked about 3 of them, and there's several more who are developing this application store where we will now port all these applications into an SDN environment and program the network using these application intelligence. Gartner calls this application fluent networks. That is what we're trying to do. We're trying to make sure that the application is detected by the network and the programming happens automatically. So that's what we're doing. If you're a customer who are looking at deploying SDN, your goal would be to start with what applications you have on your network, try to figure out which ones you want to optimize and effectively manage, and then work with an SDN controller, which is open standards based, to write the application API, and then have the ability to program the network using the SDN controller. Now, every time people say, this SDN controller thing, it looks like a single point of failure, right? Because, hey, if the SDN controller goes away, then how am I going to program my network? It is not. It is, you can have a distributed architecture of an SDN controller. So you can have a failover SDN controller, or you can have a distributed SDN controller architecture as well. That is something we are developing as well. So you'll see that it's not, it's not this bottleneck which you're creating. It's a scalable environment of controllers which can manage thousands and thousands of switches across a huge network. And some of the networks, especially in India, specifically talking about India as a market, you look at a lot of banks who have a lot of branch offices where they do not want to send really humans to go configure a switch. They're looking, you look at ICICI Bank, you look at any bank, the 10,000, 20,000 branches they have. If you look at them and you look at these environments, that is where you can see this automation and scale really reaping good benefits. You look at the Department of Post in India, huge environment of branches. They're looking at something like this which can enable the concept of configuring automatically based on application needs. So the goal which we are trying to provide from an HP perspective is to really make sure that this concept is simple enough. We can make the switches, the controllers, the applications open standards based, which is very, very important, so that in a multi-vendor environment, you can work with third-party controllers, or you can work with third-party switches, right? So we are making sure that we build an open standards environment. We build a converged server, storage, network, software, services solution for our customers. And then finally, we are driving key automation. That is, you define rules, you define policies based on the application, and then you program the entire network automatically. Right? That is the concept behind SDN. That is the promise of what SDN can do. So we believe, at least at HP, that we are changing the paradigm of networking. We are moving away from speeds and feeds. We are moving to more automated environments of programmability where you don't basically need human middleware. So we are driving that, and we are pioneering that innovation. And we have a lot of engineers in Bangalore here locally working on, within HP, working on the SDN controller and working on the SDN enabled open flow switches. So if you visit the HP office, some of you are from HP, but if you visit the HP office in Whitefields, right? If you do that, then a lot of the people here locally are building this technology and innovation into the HP networking portfolio. So it's a significant investment we're putting in SDN, and we're driving this concept of a paradigm shift to really see how this kind of technology can make benefits from an application perspective in the networking space. That makes sense? Right? I know I'm trying to save some time so that Vijay can also take his flight to Delhi, so I can also take my flight to Chennai tonight, and I know we're running a little late, but that was the quickest presentation I've done on SDN so far, I think. But I just wanted to get you the concept of what SDN is and how it can reap benefits to you and your customers in your networking environment. Hopefully this was informational. If you have any questions, don't call me. No. If you have any questions, I have my entire HP team here, sitting here, who can answer a lot of your questions technically and from a business perspective. So hopefully this event is good for you. And now I give it back to Mr. Paul. Thank you very much for your time. Yeah.
So, very nice. Any question, please?
Yes, sir.
Yeah.
In the SDN perspective, I think I am audible, right?
Yeah, absolutely.
Yeah. So how you are involving academia into that?
Yeah. Very good, very good. We have some folks from academia here as well. So how are we doing in academia? There's two ways we are doing it. The first way is, I talked about the application development, right? So I'll give you an example. We have 3 universities. We have Indiana University in the US, who are building another load balancing application. So they are involved from a application development perspective, because academia is more research oriented, and a lot of the research is really happening in the application space. That's one. The second space we're working with academia is to define the standards which enable the communication between the infrastructure layer and the controller, and the application layer. So whether it's the open flow actual standards body or standards work. So in 2007, HP worked on a project called Ethane, with Stanford University and Berkeley University, which is where OpenFlow emerged as a standard. So we're working very, very closely with a lot of the US universities. We're working very closely with the Indian universities. We're working very closely with IIITB here locally in Bangalore in driving some of the technology requirements in this space, right? So that's the two areas. One is the app development, and second is the actual definition of the standards, which are defining the communication between the controller and the infrastructure, or the controller and the app. Did I answer your question? Yes? Are you from academia?
Yeah.
Oh, okay. No wonder you asked the question. Yes. Maybe we can talk. Any other questions?